All right, here are two more questions. On 37, just find the roots of that polynomial. On 38 here, I want you to multiply this out. So square this expression here. Multiply this out, square that expression, multiply that out for me. All right, so let's have a look. All right, if I'm going to find the roots of this expression, I need to set it equal to 0. So 0 is equal to x to the 4th plus x to the 3rd plus 5x squared plus 5x. All right, notice that each term has an x in it, so we can factor out an x. All right, and then that'll leave me with x to the 3rd plus x squared plus 5x plus 5. All right, I have 4 different terms. Usually if you got 4 terms, the trick that you're going to try to pull is to factor by grouping. Factor the first 2 and then factor something out of the second 2 terms. So let's try that. And instead of those parentheses, I'm going to use brackets here so that we can use some more parentheses. All right, so I have 0 equals x times. Here, out of the first 2, I can factor an x squared. And that will leave me with x plus 1. X squared times x is x cubed. X squared times 1 is x squared. Out of these 2, I can factor a 5. And that will leave me x plus 1. So 5x plus 5 works. All right, and then just like magic, notice that there's an x plus 1 in the first term, an x plus 1 in the second term. So now we can factor out the x plus 1. So we have 0s equal to x times x squared plus 5 times x plus 1. Right, so I factor in the x plus 1 to the outside. That left me with x squared plus 5. And I really don't need these anymore because all I'm doing is multiplying them. All right. If you're multiplying these 3 expressions together and the answer is 0, then any one of those could be 0. So either x equals 0, there's one root, or x squared plus 5 equals 0, or x plus 1 equals 0. All right, so this would be x equals negative 1. So we found 2 roots so far, 0 and negative 1. All right, here we subtract 5 from both sides. X squared equals negative 5. Take the square root of both sides. You get x equals plus or minus the square root of negative 5. Remember, you get 2 solutions. Square root of a negative number is imaginary. So hopefully you can see this. I have x equals plus or minus the square root of 5i. All right, so I have 1, 2, 3, 4 roots. Notice the order of this expression or this function is 4. And I've got 4 roots. These 2 roots are real. These 2 roots are imaginary. All right, let's have a look at 38. All right, so if I'm going to square this expression, that means to multiply it by itself. So that'll be 3 to the x minus 1 times 3 to the x minus 1. All right, and then I just distribute it out. So 3 to the x times 3 to the x. All right, let's be really careful here. So if I multiply 2 numbers together with the same base, I should add the exponents. So x plus x is 2x. So that'll be 3 raised to the 2x power. Right. X plus x is 2x. Right. And then I have 3 to the x times negative 1, so that's minus 3x, 3 to the x, minus another 3 to the x will give me minus 2 times 3 to the x. And then negative 1 times negative 1 is plus 1. All right, there are a couple of different ways that you can write this 3 to the 2x. So one way would be 3 to the x squared. Because remember, in this situation, you would multiply these exponents. So 2 times x is 2x. So I can write it that way. I could also write it as 3 squared to the x power. Because again, 2 times x is 2 times x. If you write it this way, then you can simplify. 3 squared is 9. So that would be 9 to the x power. All right, so let's multiply these two. Notice these are conjugates. So we should get a difference of squares when we multiply together. 3 to the x times 3 to the x, we've already done that. That's 3 to the 2x, which we could rewrite in either of those ways. All right, and then we have plus 3 to the x, minus 3 to the x, so the middle terms cancel, as usual when you're multiplying conjugates. And then minus 1 times plus 1 would just be minus 1. All right, let's square this expression. So again, that means to multiply it by itself. And 6 times x over 2 minus 1. All right, so here I have 6 to the 1/2 x times 6 to the 1/2 x. I would add my exponents. So half an x plus another half an x is 1x. So that would be 6 to the x power. Half an x plus another half an x is 1x. Right, and then I have minus 6 to the half x minus another 6 to the half x would be minus 2 times 6 to the 1/2 x. And then negative 1 times negative 1 is plus 1. All right. And then the last one, we're multiplying two conjugates, so the middle terms are going to cancel. First times the first, we've already done that. That'll give us a 6 to the x. The middle terms cancel, and you get a minus 1 on the end. All right, try these two problems. All right, let's have a look. All right, so I want to write the first 5 terms of this sequence. Remember, this is what we call a recursive function. Okay, in order to know the n plus first term, we have to know the term before it. So for any term in this sequence, we have to know the one that came right before it in order to find that. So they will tell you what the first term is. So here they tell us that A0 is equal to 4. All right, so if A0 is 4, then 4 will be our first term. So we'll let n be 0. So this number will be 4. If n is 0, this number is 4. So negative 2 times 4 is negative 8. Negative 8 plus 3 is negative 5. All right. So now to find the next term, we'll put the first term, or we'll keep these straight. That's 0. This is 1. All right, so now we're going to put n being 1 right here. So a sub 1. And that'll tell us what a sub 2 is. 1 plus 1 is 2, so that'll tell us a sub 2. All right, so this is negative 5. Negative 2 times negative 5 is 10. 10 plus 3 is 13. And then we're going to let n be 3. All right, so we're going to put 13 in here. Negative 2 times 13 is negative 26. Negative 26 plus 3 is negative 23. Now we're going to go with number 4, which will actually be our 5th term. So a sub 4, so n is 4. That'll give us 5. So we're going to put in negative 23. So negative 2 times negative 23 is 46. 46 plus 3 is 49, and I got the first 5 terms of that sequence. All right, so we have this population that's given by this function after t months. There's my t. I want to know when will the population reach 2,838. So here's my population. So I have 2,838 equals 2,000 e to the 0.05 t. All right, so to solve this, I need to isolate this part, the e raised to the variable. So I'm going to divide both sides by 2,000. When I do that, when I divide both sides by 2,000, I use my calculator here, I get 1.419 equals e to the 0.05 t. Right. Now, to undo this exponent, to get the t out of the exponent, I need to take the natural log of both sides. So I'm going to do the natural log of 1.419 equals the natural log of e raised to the 0.05 t. All right, the natural log of e raised to this will just be that exponent. So that'll be 0.05 t. And here we still have the natural log of 1.419. All right, so now to solve for t, I'll divide both sides by 0.05. So that will give me t equals the natural log of 1.419 divided by 0.05. And then we can ask our calculator to give us an approximation to that. So the natural log of 1.419 divided by 0.05 gives me approximately 7. So 7 months. Right. Let's check that, make sure it really works, because if we have multiple choice, we could just plug in numbers and see. So if I put a 7 in for my t, so that would give me 2,000 e to the 0.05 times 7, which is 0.35. All right, so then I can just ask my calculator what 2,000 times e raised to the 0.35 is. And I find that that's approximately 2,838 point something. So it's really close to the right answer. So we can be confident we got it right. All right, try these 2 problems. All right, let's have a look at 41. So here we have a sequence. I've given you the ends and then the sequence values. Is the sequence increasing or decreasing? Well, that's pretty easy. Obviously it's increasing. 5/9 is the smallest, 5/3 is a little bigger, then obviously it's going up from there. So definitely increasing. Very easy. Is the sequence arithmetic? Remember that arithmetic means linear. Is there a common difference? Is it going up by the same number each time? So we look here and it's going up by 10, and then it goes up by 30, and then it goes up by 90. So it's not going up by the same amount each time, so it's not arithmetic. So that's a no. And what is the common ratio? So what is the pattern here? Well, you can see that we're multiplying by 3 each time. 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. And the same here. 5/3 times 3 gets me a 5. 5/9 times 3 gets me 5/3. So the common ratio is 3. Now, since we have a common ratio, we know that this is a geometric sequence. And which means that it's exponential. So this is an exponential function. All right, so which one of these systems of equations has exactly one solution? Well, let's think about it. So here, I have two linear functions. The y-intercept is at 2, and the slope is 3. So the first one looks like this. The second one has the same slope but a different y-intercept down here at -5, but it has the same slope. So the same slope but two different y-intercepts. So those lines will never intersect. So this has no solution. Okay, so that's not exactly 1, so this one's out. All right, let's look at this. So I got y equals 4x minus 1. Let's put the second one in the same form, y equals. So I'm going to add 8x to both sides. Gives me 2y equals 8x minus 2. Divide everything by 2, and I get y equals 4x minus 1. Notice that it's the exact same equation. So these two lines sit right on top of each other. So this has an infinite number of solutions. Infinite solutions. The two lines sit right on top of each other, so there's an infinite number of solutions. That's not exactly 1, so that one's out. All right, let's have a look at this one. Here we have y equals x squared. That's easy to graph. That's a quadratic. You can graph that in your sleep. It's a parabola that looks like this. And we have y equals 9. That's a constant function right here at 9. So it goes like this. And you can see that this has 2 solutions. All right. That's not exactly 1, so that one's out. So it looks like it's going to be C. Let's think about it. If I were to graph the absolute value of x, you guys remember graphing that. Makes this V shape. Looks just like that. And I also have the line x plus 3. So that's here. All right. And the slope is 1, which is the exact same slope as this. On this side, this was y equals x. So we go up like that, and down like that. Okay. And it has the same slope as this half of the absolute value. So you can see that this one has exactly 1 solution. So exactly 1 solution. All right, so that's the right answer. All right, so try these two problems. All right, let's have a look at it. All right, so here I've given you a graph. The domain, remember, is all the x values that you can plug in to the function. So my domain goes from 0 out to 12. We have closed circles here and here. So remember that this point is included and that point is included. So I'm going to use square brackets. All right, the range is all the y values, or all the numbers that the function spits out. So the range goes from 0 up to 10. And the 0 and the 10 are both included. So again, I'll be using square brackets. Remember, if that point's not included, you use open brackets or parentheses. All right, the maximum value of my function. So when x is 5, the maximum value of the function is 10. Okay, so it takes on its maximum value of 10 at x equals 5. All right, and then what interval is the function increasing on? So the function is going uphill from 0 up to 5. So on this interval right here, it is increasing. All right, it's not increasing at 5 because it's flat up there. So we'll use an open parenthesis. And since it kind of stops right here, it's kind of hard to say what it's doing at 3. We'll say that since it's cut off on the other side of 3, that it's not increasing there. That's kind of hard to say. That could be a square bracket or an open parenthesis. All right, let's look at 44. All right, so we have theta is in the fourth quadrant of a unit circle, and we know what cosine of theta is, and we want to figure out sine. So here's my unit circle, and we want theta to be in the fourth quadrant, so let's draw our triangle down this way, and then I'll put the rest of it in. You guys remember how to do this. Since this is a unit circle, remember that the hypotenuse of this triangle would be 1 because the radius of the circle is 1. And let's draw our theta right here. All right, so for this triangle, cosine of theta is the square root of 3 over 2. Remember, cosine is adjacent over hypotenuse. So relative to this angle, this is my adjacent side, square root of 3 over 2, and my hypotenuse is 1. We want to figure out what the sine is. Remember, sine is opposite over hypotenuse, so I need to know this side right here, length of that triangle. All right, so we can use the Pythagorean theorem, which says that a squared plus b squared equals c squared. So we would have y squared plus a square root of 3 over 2 squared equals 1 squared. And probably if you remember all the trig stuff, you already know what the points are on that point, but we can figure it out. All right, so we have y squared plus, all right, if I square this, then I multiply it by itself. So I have on the top square root of 3 times the square root of 3, which would be 3. And on the bottom, 2 squared is 4. We get 3/4, and that's 1. I subtract 3/4 from both sides. 1 minus 3/4 is 1/4 equals y squared. So y is going to be the square root of 1/4, which would be 1/2. All right, so we know the length of this side is 1/2. All right, but remember we're down here in the fourth quadrant. 1, 2, 3, fourth quadrant. So my x value of this point was the square root of 3 over 2 this way. But the y value will be negative. So that's going to be negative 1/2. Okay. So sine then is opposite over hypotenuse. If the opposite side is negative 1/2, hypotenuse is 1, that'd be negative 1/2 over 1. So my final answer would be negative 1/2. All right, try these two. All right, let's have a look. So we have 8 to the 5th raised to the 1/3. So one thing you could do is do 8 to the 5th first, and then raise that to the 1/3. But 8 to the 5th is a really big number. I can't do that in my head. I can do it if I had a calculator. No. So let's use some exponent rules. Remember that I can multiply those two together. So this would become 8 to the 5 times 1/3, or the 5/3 power. Remember that if when you raise to a fraction, the denominator tells you the root, the numerator tells you the power to raise it to. So this would be the cube root of 8 to the 5th power. The cube root of 8 is 2, so I have 2 to the 5th. And I can figure out 2 to the 5th fairly easy. That would be 32. All right, the next one, write a recursive formula for this sequence. And we're going to start with A1 equals 5. So if a recursive formula, remember, means that to find the next number in the sequence, I have to know the one right before it. So a to the n plus 1 is equal to a to the n, so the one before it. Some more room. All right, so how's this going to work? So what am I going up by each time? Well, I'm going up by 2, so I'm going to need 2 times a to the n. All right, but where do I start at then? Oh, sorry about that. I'm not multiplying by 2 each time. I'm adding 2 each time. So we'll go with the one before it. I just add 2, and that'll give me the next one in line. So let's check that out and make sure it makes sense. So A1 should be 5. So I'm going to put a 5 in my here. So A5 plus 2 gives me the next one. That'd be 7. So to find the first term, I already know. To find the second term, I'll let n be 1. So that's A1, which is 5 plus 2 is 7, gives me A2. Okay, to find the A3 then, I'm going to put A2 in. A2 is 7. 7 plus 2 is 9. So I'll have my formula there. All right, try these two. Okay, so we want to simplify this. Remember that you can break these apart. So this would be the square root of 49, square root of x to the 8th, and the square root of y squared. Square root of 49 is 7. Square root of x to the 8th would be x to the 4th, because if I squared that, x to the 4th squared, I would multiply and get x to the 8th. Square root of y squared, of course, would just be y. So we have it simplified there, assuming that x and y are positive numbers. All right, find the average rate of change. Remember, the average rate of change is just the slope of the secant line that goes through those points. So the average rate of change, remember our definition to that was f of x2, which would be 5, minus f of x1, which would be 3, all over 5 minus 3. So y2 minus y1 over x2 minus x1. It's just the slope. All right, so then it's all just plugging numbers in. So f of 5, I'll put 5 in. That's 25. Minus 5 is 20. Plus 2 is 22. Minus 3, that's 9. Minus 3 is 6. 6 plus 2 is 8. Over 5 minus 3. 22 minus 8 is 14. 5 minus 3 is 2. So my average rate of change would be 7. All right, try these two. All right, so what is the remainder when f of x is divided by x plus 2? So one thing you could do is just do long division and divide this all by x plus 2 and see what the remainder is. But remember, we have the remainder theorem that says if you divide a polynomial by x minus a number, then all you have to do is plug that number into the function to see what the remainder is. So here I'm dividing by x minus negative 2. So all I need to do is plug negative 2 into this function, and I'll know what the remainder is. So extremely easy question. So negative 2 to the 3rd, that's negative 8. Negative 2 squared is 4 times negative 5, that'd be minus 20. And then minus 2 minus 1, so negative 31 would be the remainder. All right, let's solve this equation for x. Remember, to solve log equations, you should isolate the log by itself. So I'm going to add or subtract 5 from both sides. So y minus 5 equals negative log of x. And I want to get rid of this negative sign, so I'm going to divide both sides by negative 1. So this will become 5 minus y equals log base x. All right, remember that if you just write log, then there's an understood base at 10. And then we just use the definition of logarithm, which says 10 raised to this is equal to x. So x equals 10 raised to that power. And we're done. We have it solved for x. All right, last question. Graph this quadratic function. All right, so let's have a look at it. Let's find the roots first. So to find the roots, of course, you just plug 0 in for f. We have 0 is equal to negative 2x squared plus 4x plus 30. Let's divide both sides by negative 2, since 2 will go into every term. 0 divided by negative 2 is just 0. I have x squared minus 2x minus 15. Then I can easily factor this into minus 5 and plus 3. All right, if I multiply two things together and the answer is 0, then either of those can be 0. So either x minus 5 is equal to 0, or x plus 3 is equal to 0. So either x equals 5 or x equals negative 3. So I have my two roots. Let's graph those. So we got one root at 5 and one root at negative 3. All right, so I know my vertex then will be, the x value of my vertex should be halfway in between those roots. So halfway between the roots would be at 1, x equals 1. That's 4 this way, 4 that way. So I can just plug 1 into this function to get the y value. So if I do that, that's negative 2 plus 4 is 2 plus 30 is 32. So there's my vertex. I know this opens down because the leading coefficient is negative. So it's going to look like this. Decent looking parabola. Let's make that a little better. All right, and then let's find the initial value. I can always do that by plugging 0 in for x, which would give me a 30, right there where it should be. So I've graphed that parabola.